Welcome. Today we are performing a practical on linear regression. That's our first practical. Before that, let's see about the vision of the institute. That is fostering technical excellence through ethics, sustainable education, innovation, and research. Mission of the institute to impart high quality technical education through innovative and interactive learning process and high quality global recognized institutional programs, fostering a collaborative scientific temper among students with ethical responsibility towards the society, preparing students from diverse backgrounds to have aptitude for employment, entrepreneurship and research with a spirit of professionalism, and last one, to contribute to nation's sustainable development. Let's see vision of the department to produce competent electronics and telecommunication engineers with a commitment to serve society. Mission of the department: first, deliver innovative ICT enabled and interactive learning fostering excellence in electronics and telecommunication engineering. Second mission, cultivate scientific inquiry, ethical responsibility and collaboration to address societal and technological challenges effectively. Third mission, empower diverse students with skills for employment, entrepreneurship and research, nurturing professionalism and lifelong learning. Let's see program educational objective of the department. PO1, graduates will apply engineering knowledge and innovation to solve complex problems in electronics and telecommunication domain. Second, graduates will demonstrate ethical and social values while adapting to technological advancement for sustainable societal progress. Graduates will pursue careers through employment, entrepreneurship, or research, embracing professionalism and continuous learning throughout life. And program specific outcomes of the department are: first, communication system. Design and analyze analog and digital communication system for wireless, optical, and network based applications. Second, PSO, signal processing and embedded systems. Apply signal processing and embedded system design using modern tools to develop intelligent system automation and smart electronic product. The subject prerequisites are mathematics for telecommunication engineering and second subject digital signal processing. We have four course objective. That is, first one, recall key concept and fundamental relevant to machine learning and applications. The Bloom's level is L2, that is understand. Description is understand. Second one, understand the theoretical foundations of linear, non-linear models and the principles behind probabilistic and advanced machine learning models. Bloom's level is L2 and Bloom's description is understand. Third CO is apply various machine learning and signal processing algorithms and techniques in problem solving. Bloom's level is L3 and Bloom's description is apply. Fourth CO is analyze and perform the suitability of different learning techniques for specific applications. L4, analyze. Let's start our practical. That is, first step for all the machine learning practicals, we have to import libraries. Let's see some basic concept about the linear regression. At its core, linear regression is supervised learning algorithm used to model the relationship between a dependent variable and one or more independent variable by fitting a linear equation to observed data. To start with, import First step is to start with the import. We import our tools. We use the pandas for data handling and matplotlib for visualization. The heart of our practical is scikit-learn, which provides the linear regression class, the mathematical engine that will find the best fit line for our data. Next step, step 2, that is mount Google Drive and load the data. There are many ways to load the data, but we are using this method for uploading the data. We are using a data set student performance. Let's see the data set. This data set shows many features like gender, race, ethnicity, parental level of education, lunch, test preparation course, math score, reading score, writing score. For our practical, we are considering these three features like a reading score and writing score for predicting the math score. Let's upload this file. And copy the path and paste in this section. After loading our student performance data, we must identify variables. Sorry, I forgot to run previous one command. And then this. Okay. In linear regression, the target is dependent variable we want to predict. In this case, the math score is our target. The feature X are the independent variable we believe influence that score, which are the reading and writing. In step 3, we are understanding the data set, that how many columns are there in the data set. Let's see, like a gender, race, parental level, and whether the data set is having a null value or not. And also we have to check the data type of our data set. Then we are selecting the features like independent variables are our reading score and writing score, and dependent variables are math score. Next step is the training process. We split our data into training and testing sets to ensure our model can generate to new information. When we fit or train the model, the algorithm is mathematically calculating the optimal coefficient that minimize the distance between the actual data points and the regression line. Next one, interpreting the model parameters. In this step, we are splitting the data set then create and train the linear regression model. And next step, we are finding the intercept and coefficient of best fit line. This is the intercept and these are the coefficients. As we are getting two coefficient because we have two independent variables. Next one, the prediction and model evaluation. Model parameters are crucial for the understanding. The coefficient represent the weight of each feature. For example, a coefficient tells us exactly how much the predicted max score is expected to change for every 1 point increase in the reading or writing, assuming other factors stay the same. Let's evaluate the accuracy. Once we make prediction, we must evaluate them. We use mean square error to measure the average square difference between our prediction and actual values. We also look at the R2 score or the coefficient of the determination, which tell us what percentage of the math score variance is explained by our reading and writing features. Then visualize it. In visualization, we are using the matplotlib library. On x-axis it is actual math score, and y-axis it is a predicted math score. Visualization brings it all together. By plotting actual versus predicted values, we can see how well our data points cluster around the identity line. The closer points are to the line, the more accurate our linear regression model is. And last one but not least, that is the practical application and conclusion. That's here we are taking a single prediction example. We are taking value like 40 and 65 as a reading score and writing score. On the basis of that, we are predicting our math score. Like finally, we apply the model to the single case by inputting new reading and writing values. Our regression equation calculates the predicted math score. This demonstrates the power of linear regression in transforming historical data into a predictive tools. Thanks for joining this session. Thank you.